Okay, so these are your video notes over writing equations. So before we get into word problems, we're going to fill in this chart with some common phrases that you'll see in which operation they are related to. So we're going to start by looking at phrases related to addition. So sum, total, in all. Interesting. All together. In addition to. And more than. This is not all of the phrases, but if you do see one of these phrases, you do know that you are going to be using addition. Next, we're going to look at subtraction. So difference, less than, minus, or fewer. Multiplication, we have per, for each.
Ms. Hartman, can you please come to the front office, Ms. Hartman?
Product, times, and every. And then lastly, we have division. Division, usually the only word you're going to see in our word problems is quotient. The quotient of x and a number that tells you you're going to take your variable x and divide by whatever number they give you. So again, this is just for reference. So when you're reading through a word problem and you're not sure what operation to use, come back, you can look at this, see if you find any of these phrases, and then use that appropriate operation. On to the back. Write and solve an equation for each scenario below. So number 1, 4 more than 7 times the number is the same as 20 less than 3 times the number. Find the number. So we're going to analyze this sentence and kind of break it into pieces. The first thing I want to point out is this phrase here, is the same as. So as we're writing equations, whenever you see is the same as, that's your equal sign. So on the left hand of my equal sign, we have this part right here. 4 more than 7 times the number. So we don't know what this number is, but we know it's going to be 7 times that. So because we don't know what this number is, that's going to be our x. 7 times the number is going to be 7x. And then we also know that we need 4 more than that. So if you look at the front, you'll see the phrase more than tells us we need to add. So we're going to take our 7x and add 4.
Vasquez and Miranda Vasquez, please come to the front office.
On the other side, 20 less than 3 times the number. So again, we still have that phrase, the number. So that's our x. And now we have 3 times that. So that's going to be 3x. And last, 20 less than that. Less than means subtraction. And then 20. So there's our equation. 7x plus 4 equals 3x minus 20. To solve, we're going to use our inverse operations. Take away 3x from both sides. I'm sorry, I didn't leave you much room to solve. We get 4x plus 4 equals negative 20. Take away 4. 4x equals Negative 20 minus 4 is negative 24. And we're going to divide by 4. So x equals negative 6. So our mystery number is negative 6. Let's try that again with number 2. Lenny makes $55,000 and is getting annual raises of $2,500. Carl makes $62,000 with annual raises of $2,000. How many years Y will it take for Lenny and Carl to make the same salary? So the same salary, again, we're going to be using an equation. When you have word problems like this, generally, one person is going to be one side of the equation, and the other person will be the other side. So Lenny is going to be the left-hand side of our equation. He makes $55,000. So that's what he starts off with, $55,000. And he's getting annual raises of $2,500. So annual raises means he gets that much money per year. So per means we're going to be multiplying. We're looking for Y, the number of years. And so if he makes $2,500 per year, it's going to be 2,500 Y. We're going to add those together, and that's going to be his total salary. Carl, he's the right-hand side of our equation. He's going to be set up the same. He starts with a salary of $62,000. And his salary raises or goes up, so addition, by $2,000 per year. So that's where our variable comes in. And then to find out how many years it will take, we're going to solve for our variable Y. So subtract the $55,000 from both sides. $2,500Y equals 7,000 plus 2,000Y. And then we're going to take away 2,000Y from both sides. So we get 500Y equals 7,000. And then last, we're going to divide by 500. So Y equals 14. So after 14 years, Lenny and Carl will have the same salary. Okay, last we're going to do number 3. I'm going to walk you through setting it up again one more time, and then I want you to finish solving number 3 on your own, and we will check that as you walk into class tomorrow. So number 3, a container has 300 liters of water, and a second container has 700 liters of water. The first container begins filling up at a rate of 5 liters per minute, and at the same time, the second starts draining at a rate of 6 liters per minute. How many minutes will pass until the containers have the same amount of water? So same equals. So our first container starts off with 300 liters of water. So 300 liters of water is where it's starting. It begins filling up. So filling up tells us we're going to be adding at a rate of 5 liters per minute. So per minute, that word per tells you where our variable goes. We don't know how many minutes it's going to take, but it's going to be 5 liters for every minute M. Our second container starts with 700 liters of water and is draining at a rate of 6 liters per minute. Draining means it's losing water, it's going down. So we're going to be subtracting on this side. 6 liters per minute. So again, that per tells us it's going to be multiplication, and we don't know how many minutes, so that's going to be M. So our final equation is 300 plus 5m equals 700 minus 6m. So go ahead and solve that and have your answer ready as you come to class tomorrow.